Okay, today in Algebra I we're going to do 8.2, which is a section on negative exponents and exponent of 0. Before we start with notes, we'll go over the basic law of exponents. If you take x to the fifth divided by x to the second, well, x to the fifth is x times x times x times x times x. X to the second is x times x. So you can reduce this down to this x divided by that x is 1, and this x divided by that x is 1. So what's left on the bottom is just 1. What's left on top is x times x times x is x to the third. Okay, now you can take a shortcut rather than write all these x's and cross out the ones they have in common by using the law of exponents, which says if you divide common bases, you can subtract their exponents. So x to the fifth divided by x to the second is x to the third. Okay, so taking that on a little bit, what if we have the other way around? What if we had x to the second divided by x to the fifth? Again, x times x is x to the second. And then x to the fifth. Okay, so we cancel out our common x's. Now remember, x divided by x is not 0. X divided by x is 1. X divided by x is 1. And 1 times 1 on top is 1. Then on the bottom we have 1 times 1 times x times x times x, which is x to the third. So by expanding these out into regular multiplication and then crossing out your common factors, it leaves 1 over x to the third. If I follow the law of exponents, like we did in the previous example here, we're going to subtract the exponent. So x to the second divided by x to the fifth is x to the 2 minus 5, which is x to the negative 3. Now here we had x to the third on both ends. So it was true going both ways. So what's equal on this side and that side, they're equal to each other. In this case, that would be the same thing. So here, if it's true going this way and it's true going that way, that must mean my two results are equal to each other. All right, so that is the basics of what negative exponents get you. X to the negative third power is equal to 1 over x to the positive third. I'm going to say this a lot of times during this lesson and before we go all through chapter 8. Negative exponents have nothing to do with the sign of the base. Negative exponents tell you to take the reciprocal of the base. So x to the negative third means you go 1 over x to the positive third. You take the reciprocal of the base. The reciprocal of x is 1 over x. Negative 3 becomes positive 3. Okay? Now, using that same logic for 0 exponents, if I have x to the third divided by x to the third, okay? We expand those again. Okay, and again, x divided by x, not 0, it's 1. X divided by x is 1 on top, 1 on the bottom, and x divided by x, 1 on top, 1 on the bottom. So on the top we've got 1 times 1 times 1, which is 1. And on the bottom I've got 1 times 1 times 1, which is 1, and 1 divided by 1 is 1. So expanding, crossing out common factors gets me 1. Using the law of exponents, or if we divide common bases, we subtract their exponents, I get 3 minus 3, which is x to the 0th power. Okay, so once again, if it's true going this way and true going that way, then my two results must be equal to each other, which means x to the 0th power is 1. Okay, now that being said, any base to the 0th power is 1. Not 0, it's 1. And it doesn't matter how complicated it is. If I have 15,000 to the 0th power, what's that equal to? 1. Now, this is a good time to talk about parentheses and what's included and what's not included. Okay, so x to 0, so just 2. 2 to the 0th power, what's 2 to the 0th power? 1. How about if I write this, negative 2 to the 0th power, what's that equal to? Okay, so I'm going to say 1 or negative 1, one of those two, right? The rule is, if the negative sign is not inside parentheses, it's not included. So it's called the thumb rule. If I can cover up the negative sign, it's not included. So what's 2 to the 0th power is 1. Now it's negative 1. Okay, so the difference between this problem and that problem is here I can't get to the negative sign. It's protected by parentheses, which means it is included. So the base is both negative and the 2, negative 2. So any base to the 0th power is 1. So parentheses and negative signs really play a huge part in this lesson. So when you're simplifying these, you really need to be aware of that. All right, 8.2, 0 and negative exponents. Okay, the definition of 0 and negative exponents says let a be a non-zero number and let n be a positive integer. A non-zero number to the 0th power is 1. A to 0th equals 1 as long as a is in 0. So you don't do 0 to the 0th power. Okay? And then a to the negative n is the reciprocal of a to the positive n. So a to the negative n equals 1 over a to the positive n. And again, a can't be 0 because you can't have or 0 in the denominator. Right? So negative exponents have nothing to do with the sign of the base. It tells them where they're going to go. If it's on top, it goes to the bottom. If it's on the bottom, it goes to the top. Make some examples. 4 to the negative 2. So the negative 2 means the 4 is going to go to the bottom. It will be positive 2. And then 4 to the 2nd power is 16. Okay, so 4 to the negative 2 is 1 over 4 to the positive 2, which is 1 over 16. Okay, in B, we've got in parentheses negative 5, and then 0 exponent on the outside. So negative 5 to the 0th power, the negative sign is included, so the whole thing's to the 0th power is what's going to be 1. Now here you can't see that negative sign. It's 7 to the negative y. Okay, so we don't have to do a lot of arithmetic there. What does a negative exponent do to the base? Is it makes it go to the bottom, or it will be positive. So 7 to the negative y would be 1 over 7 to the positive y. Okay, now when you have a fraction inside parentheses to a negative exponent, the negative exponent means you take this fraction and take its reciprocal. So what's the reciprocal of 1/9? 9 over 1, or just 9, and then 9 to the 1st power is just 9. Okay, and then 0 to the negative 2. Well, we talked about up here, a can't be 0 if you take a negative exponent. So 0 to the negative 2 is undefined because 0 has no reciprocal. Okay, there's the basic example 1. Get a little more complicated here with example 2. Okay, so we've got 7 times 4 to the negative y. Now the 7 has no exponent other than 1 that's not showing. So 7 is not going to the bottom. It does not have a negative exponent. 4 has a negative exponent. It's going to the bottom. Okay, so it's going to be 7 over 4 to the positive y. I don't know what that extra blank's for. The 7 would go on top. 4 to the negative y would go to the bottom, or it would be 4 to the positive y. Okay? When you're doing problems like this, you just have to pay attention. What has a negative exponent and what does not? The negative 4 is on the x, not on the 3. The negative 5 is on the y, and also not on the 3. So when the exponent doesn't, the 3 doesn't have an exponent that's showing, that means its exponent is positive 1. So it's going to stay on top. X to the negative 4 is going to go to the bottom. So 1 over x to the positive 4. Y to the negative 5 also going to go to the bottom, where it will be y to the positive 5. Now you can skip this step in your work. When you're doing your work, when I do this, I just make a fraction bar and figure out what's going to be on top, what's going to be on the bottom. Where's the 3 going to be? On the top. Where's the x going to be? On the bottom. Where's the y going to be? On the bottom. And when if they start out negative and you move them, they become positive exponents. That would be 3 over x to the 4th, y to the 5th. Okay, now we did, in 8.1, we did the power of a product rule, which means everything in these parentheses will be to this exponent. So it's going to be 6 to the negative 2, and then d to the negative 2. So it looks something like this. Okay, now those both have negative exponents, so they're both going to go down. So it'll be 1 over 6 to the positive 2, and 1 over d to the positive 2, which is going to be 1 over 6 times 6 is 36, and then d to the 2nd power. Okay, so if it's inside parentheses with an exponent on the outside, everything in there is going to be to that exponent. Okay, now they're kind of doing some confusing stuff here. This is really not necessary. What's the exponent on the c? It's negative. Where does it want to go? Go to the top. C to the positive 2x. If it has a negative exponent, it's in the bottom, it goes to the top. It's on the top, it goes to the bottom. Okay, more examples. Example 3, we've got 2 to the 4th times 2 to the negative 4. Now again, in 8.1 we learned if you multiply common bases, you add those exponents. So 4 plus negative 4 is 0. And what's any base to 0th power? 1. Okay, in 8.1 we also learned when you raise a power to a power, you multiply the exponents. So 3 to the negative 2 to the negative 2, we're going to multiply those exponents, which means negative 2 times negative 2, which is 4. And now we don't have a negative exponent at all. 3 to the 4th power is going to be 81. And then C, we've got 2 to the negative 6. Well, that negative exponent means what? It's going to go to the bottom and be a positive exponent. And then 2 to the 6th is 64. It'll just be 1 over 64. We're not going to use a calculator. We're going to leave it as that. Okay. All right, so here's some examples. That's 2 to the negative 5th. And that's 4 to the negative 3. That is scanned very well. I want you to pause the video and work through these. And then anytime, I'm going to go ahead and start working through these, and then you can turn the video on and off, and you can see how you did from problem to problem. All right, 2 to the negative 5 would be 1 over 2 to the positive 5, which would be 1 over 32. 4 to the negative 3 would be 1 over 4 to the positive 3, which would be 1 over 64. On number 3, we have a fraction with a negative 1, so that means you just take the reciprocal of what's inside the parentheses. So what's the reciprocal of 1/7? 7. On number 4, we've got 15. Now, this 15 is not being raised to the exponent of negative 1. The negative 1 is on the parentheses. So 15 just has an exponent of 1, which doesn't ever show, so 15 is just going to stay on top. Now, 1/5 of negative 1 is just like 1/7 of negative 1, is that you flip it. So what's the reciprocal of 1/5 would be 5. So what's 15 times 1/5 of negative 1? Now it's 15 times 5, which is 75. Okay, going down to number 5. Is this negative sign included to 0th power? Because it's not in parentheses, then it's not included. So you would do the 12 to 0th power first, that's 1, and then put the negative sign on it, that's negative 1. And then the second part of this, we've got 1 over 5 to the negative 2. Now, if you have a negative exponent in the bottom, just like it's in the top, it wants to go where it isn't. So 5 to the negative 2 in the bottom is going to be 5 to the positive 2 on top. 5 to the second is 25. 25 times negative 1 would be negative 25. It's hard to see that also. It's 3 times 3 to the negative 3. Okay, so the 3, what's the exponent on it if it's not showing? 1. These are the same base. What do we do with exponents? We're multiplying the same base. 3 to the 1st times 3 to the negative 3, you add those exponents. So 1 and negative 3 make negative 2. 3 to the negative 2 wants to go to the bottom, or 3 to the positive 2. And 1 over 3 to the positive 2 is going to be 1 over 9. Okay, now I know these are going to seem confusing. The more practice you get at them, the better you're going to be. 13 to the 0th power is 1, but 0 to the negative 2. That means we're supposed to take the reciprocal of 0. As soon as I get a number like that, I can't do anything. We just say this is undefined. I can't do any math with numbers that are not defined, so that would just be the answer to that problem. Undefined. Number 8, 15 to the negative 1 times 15. Now, 15 to the what? Doesn't have an exponent, so it's positive 1. Again, what do we do with those exponents? We're multiplying the same base. We add those. This will be 15 to the negative 1 plus 1 is 0, and then 15 to the 0th power is 1. And then we go through your 9 to 12. We're going to start having variables in here. It says rewrite the expression with positive exponents. Okay? So a to the negative 6 becomes 1 over a to the positive 6. Now these are, be careful doing these because you want to just move everything, but the negative 4 is on the y, it's not on the 3. Okay, so the 3 is happy where it is. Y to the negative 4 wants to go to the top. Now if there's 1 up here, 1 times y to the 4th is just going to be y to the 4th. And what's left on the bottom is 3. On number 11, everything, now because of parentheses with the exponent on the outside, everything is going to be to the 3rd power. So it's going to be 2 to the 3rd power, and then x to the negative 2nd to the 3rd power. Now again, when you raise power to power, we multiply those. So negative 2 times positive 3 is negative 6. And the y, where it doesn't have an exponent, is to the 1st power. So y to the 1st to the 3rd is y to the 3rd. 1 times 3 is 3. So now, which one of those are happy, which one of those want to move? Okay, 2 to the 3rd is happy on top. Y to the 3rd is happy on top. How about x to the negative 6? This one go to the bottom, where it will be x to the positive 6. So you just don't move everything. You only move bases with negative exponents. Okay, and then number 12 here, we're really complicated. Just work slowly. Now on this one, I would do what's inside first, and then worry about what's on the outside. So inside, we've got negative 3 over 6. So that's going to be a negative 1/2. Okay, 3 over 6 produces negative 1/2. And then x to the 3rd over x to the negative 2nd. Now I'm going to put this over here. We'll treat this as a separate problem. When you have problems like this, think about where they want to stay and which ones want to move. Now the 3x's up here, x to the 3rd means x times x times x. There's 3 x's. Down here is x to the negative 2, so there's 2 negative x's. Now where do those x's want to go? They want to go up here. Well, just because they're coming up doesn't mean these are going to go down. They're going to stay up there. So if I have x times x times x, and I move 2 more x's up there, how many x's do we have? X to the 5th. Okay, so what's inside there simplifies to x to the 5th over negative 2. And then what's the negative 1 do to this fraction? It flips it. So we'll put the negative out front, 2 would be on top, and then x to the 5th would be on the bottom. Okay, now that's about as complicated as a problem as you'll probably see some like that, but it won't be too much more difficult than that. Okay, we're not going to do the graphing, so that's it for 8.2.